Everybody. First of all, I'd like to apologize to not being able to come to Detroit to give this talk in person. I hope you're all having a great time at the conference. I wish I was there, but unfortunately it was not possible for me this year. So today I will talk about Kalix, which is a new product that Lightbend has been building for, I believe, 2 years now, and it's now available for use. My name is Renato Cavalcanti, and I'm principal engineer at Lightbend, work on the Kalix team. I guess you already have heard about Kalix during your day at the Reactive Summit this year, but nonetheless, I'll give a short introduction to it, explain our motivations to build such a product, and then give a quick demo so you get a good understanding of how it feels to build a Kalix application. But before, let's talk about Akka. If you have been following the work of Lightbend, you know that we have been providing solutions to help developers to build reactive applications. That's basically what Akka is. Akka is the most powerful and successful actor system implementation of the JVM. It has enabled developers all around the world to build reactive distributed systems without having to build everything from scratch. It's our passion to make distributed systems affordable and accessible to a broader audience. Distributed systems are hard to build, and therefore we want to provide the tooling to make it accessible to any developer out there. You can consider Akka as a runtime, where you can implement your business logic and let Akka do the heavy lifting for you. We provide very powerful tools to help you at this task. The most powerful of them, in my opinion, is Akka cluster. So think about that. Distributed databases providers like Cassandra or CockroachDB, or message broker providers, think about Kafka, they all provide cluster solutions. In the cloud era, with applications serving millions of users, data needs to be spread, sharded over many nodes, and someone needs to ensure that data stays consistent. But what about your application code? Can you also distribute your application? Well, the easy path here is to build stateless applications. And stateless means that you deploy as many instances as you need and you let the database layer take care of the consistency. The common technique used in such a scenario is the classical optimistic lock. You read data from the DB and the data is version. And when you have to save it back, you check if the version you have and the version that is in the DB is still the same. If that's the case, you can save it. If not, the process fails and needs to be retried or automatically or retriggered by the user. This technique works until it doesn't work anymore. That's pretty much fine at small scale, but not when you need to serve millions of users. This is when libraries like Akka becomes relevant. You want to be able to build applications that can take that kind of load without having to rely on optimistic locking. And that's what Akka cluster does. It will manage data over the cluster for you, including persistence, in a way that you don't need to resort to optimistic locking. So Akka is great. It allows developers to build extremely performant applications. We love it. However, the story doesn't stop here. While Akka gives you the tooling to build your own clustered applications, you are still responsible for its deployment and to maintain the whole cluster infrastructure. By that I mean you need to manage your database, you need to manage your Kubernetes cluster, you need to take care of security, just to mention a few. For those reasons, we have built Kalix. Think about Kalix as a cloud runtime for reactive and distributed applications. Kalix is built with the idea of providing building blocks that you can use to implement your business logic without having to even think about how data will be persisted, how data will be retrieved, how your application will scale out, how to manage your application cluster, and so forth. The philosophy is bring your code, Kalix does the rest. But how does that really work? So in reality, under the hood, we manage a Kubernetes cluster, as you could imagine. And in that cluster, we run what we call execution cluster. And there, when you create a project, it will live in that execution cluster. You come and you deploy your service. And on that slide, the user function on the right side is your code, the code that you're gonna write. On the left side is a Kalix proxy, and they are all together. When you deploy your user function, we put together with your container, your user function container, we put the Kalix proxy, and they will find each other, they will work together. When a request comes in, it goes to the proxy, and the proxy delivers data to your user function that has the logic. Your user function will process it and send back to the proxy, and the proxy saves the data. So if we look a little bit closer, what we have here is like your project that you create in Kalix. You deploy your code, and they all go together with the proxy. Then, as you go, and you may need more resource power, more computer power, we scale out your service to a few other nodes. But those are not stateless nodes. They form an Akka cluster. So your code on one side, they go always together with a proxy. But on the proxy side, so at some point you have, let's say, 3 pods, each of them running 2 containers on your code and what we call a sidecar, but also the sidecar in Kubernetes terms. For us, we call it's our proxy running there. So your code does not make a cluster. It's your service on one side, but the proxy that goes together with your code that are deployed together, they do form a cluster. Now, whenever, if we go back to the previous slides, I have a line showing request coming in, it goes to the proxy, and if there is data that needs to be brought to memory, it will take that from the database, put in memory, take the commands that just got in and send it to your code, the state of your model and the command. Your code will do what needs to be done and return to the proxy the new state if the state was updated. If it's an event source entity, it will return events as well that needs to be persisted. So this dance between the proxy and the code happens on each time that there is a request. Keep in mind that the proxy is an Akka cluster and it's managing the persistence, and your code is just providing the logic to be applied on the data, so you don't have to deal with persistence yourself. But how do you do that? So you start by defining your APIs using gRPC definitions. Everything in Kalix today is about gRPC. Then the Kalix tooling will generate class for you to implement. So you define an entity, an event source entity, and we generate the skeleton for you. You just have to implement it. You can test it locally using unit tests, integration tests, or you can even run the application on your computer. For that, you're gonna start your user function and also a proxy in a container, in a Docker container. So the proxy and user functions are now running on your machine, and you can just use them like to test manually if everything's working as expected. The same happens in integration test. We also start a proxy, and but then it's automated, of course. And once you are ready, you deploy to Kalix. But when you deploy to Kalix, you don't deploy the proxy. You only deploy your user function. We provide the proxy. It's included in the cloud infrastructure. So Kalix has different components that you can use to build your system. And the first one are event source entities. They are backed by a journal and use commands and events to mutate its states. Basically, commands get in, are validated, and events are emitted. The emitted events are persisted by Kalix and then applied to the model, updating its state. Event source involves capturing changes to data as opposed to overwriting existing values. Then we have also other kind value entities, another kind of entities also persisted. The difference here, they are very similar to event source entities, except that they don't emit events. They are not event sourced. They only persist the current state. And that's why we call them value entities. They are entities, but the whole state is persisted. The whole value that are in memory is persisted. On each incoming command, the model decides if the command must be rejected or accepted. If accepted, typically the command will mutate the state, and the state in its whole is persisted. Next, we have replicated entities. They are also entities, but they are not persisted. They are uniquely identified by the given identifier, but they don't go to the storage. They are distributed over the cluster. So if you have your application has 3 nodes, they will be in all of 3 of them in memory, and you mutate in one node, the change will be propagated to the others eventually. So they are eventually consistent, but in memory data structures. Think about CRDTs and distributed, eventually consistent distributed cache. Now, those are entities, and the 2 first entities, they are persisted, but in all 3 cases you can only access them if you know their ID. So you can always read the data if you know the ID. But sometimes you need to do other kinds of queries. You want to build a model that you can search that's not only based by ID. For example, you have many users and now you want to collect all users that has an email address that ends with gmail.com, for instance. For that, you need to create an index, and that's what views gives to you. So views are means to expose different representations of your model. We can generate views based on the events of an event source entity or from the states changes of value entity. Every time that you change a value entity, the whole state is propagated to your view. In the view implementation, you get the value entity state, and then you decide what to do. And it allows you to query for the entities using different fields, like using the email address instead of the unique ID. And you are free to persist or to index the way you want. You can say that you have a user, and at the view side you also use the same model, the user, that you can just search by email, or you can create another type. You can say on the entity it's about a user, but in the view it's a little bit different. It's my user view, for instance, and there I don't store the password for example. The last type of component we have are actions. They are the most simple one. They are stateless. Whenever you call an action, it will spawn a new action to receive the request, and when it's finished, the action just disappears. So they are stateless. If you put a state in there, it just gets discarded each time. And why would you use actions? Well, there are a few use cases. The most common one is the pure functions. You get some inputs, you process data, and you return. That's just pure function computations. You transform from A to B. You can also use actions as a facade in front of your entities. So the action receives the command from the exterior, from the outside, and then you do some transformation and you forward it to the entity, and the entity then responds to the action that then responds to the color. And the other options are you can also use actions to subscribe and to publish events. So you can subscribe to a topic, Kafka or Google PubSub, and push data to Kafka, Google PubSub. But you can also subscribe to the event source entities events, for instance, and push into Kafka, on a topic. And those are what we call the Kalix components, and there are a few more features we have. First, I already mentioned about the topics. We have broken integration. If you choose to deploy in Google Cloud, you get integration with PubSub, Google PubSub. Otherwise, you can bring your own Kafka. You configure your Kafka's. Usually, people use Kafka in the cloud as well. They just configure Kafka in Kalix, and then your Kalix application can start to read and push data into Kafka as well. We have timers. Timers is a functionality that you can only use from an action, and in timer you can say, okay, I want to make this call, but not now, in 5 minutes. So you schedule that call to be done in 5 minutes, and this persisted. So if you shut down your machine, your nodes at that moment, and bring them back, they will be executed. We have ACL, so access control list. You can annotate your method to say who is allowed to call it. Who, I mean anyone on internet. It's open to the internet. It's only available for the internal servers and so on. And we have JWT support. Okay, so I'd like to write a small application, give a small demo, and that's what we're gonna do right now. I will use the Scala template for that. It will create a value entity for us. I call it Kalix demo reactive summit. I just keep the default options for the versions, library versions, and then the package I call it Kalix demo. Oops. Okay, we have here our project. I will just quickly open that on Visual Studio because I want to show what is inside before I start to compile it. It has just some proto files with the definition of my entity. Here is the state of my entity. It's a counter. Well, the template comes already with a model, so you can play around with that. The goal is that you delete that afterwards and use the template to start your own model. So we'll just keep going with the counter for convenience. And it has commands, message that can be sent to it, increase, decrease, like increase the counter. And the important bit here is that we have this information telling Kalix that we want to generate a value entity to manage that state. The state in question is the counter state here. I will add one extra field here. I will say that this guy here has a name. And what is that? So we have the counter state is what is persisted, and the current counter is what I return when someone asks to get the counter. So that's my external representation. And just to make it a little bit different, I'm adding here the name. So next I will compile that, but I will open it in IntelliJ. Because then it's more convenient to work on it. So let's have a look what got generated. I have a main function which registered the counter, and I have the counter that I have to implement. So let's do it. So the counter, the first thing is what is the empty state when there is no counter there, when I have nothing in my database and I want to send my first command, from where I start. So I need an empty state or initial state. And I think the very sensible one for a counter would be something that started with a counter that starts with 0. Then when an increase command comes in, what I will do is I will create a new value that is the current state plus my incoming request. So increase value by so much. Then I have a new value, and I tell now Kalix what I want. I want Kalix to persist that, update that state. That's an integer or long, I don't remember. Yeah, an integer, and here's the state. I will just send a new state to Kalix, and Kalix will persist it for me. And then I confirm to my users that the command was accepted by sending this empty message with kind of acknowledgement. No, I will just copy this code here because it's almost the same, except that this is the decrease one, and I will do a subtraction, and when the user sends a reset, I will update the state back to 0, the empty state, and I reply, and finally the current state. When someone requests the current state, I will return this other type here, which is then reply. I will reply with demo current counter. But the thing here is I have two options. Well, first option is to pass the state. The state that is persisted is the one that is getting returned here, passed to the method, and it's counter state. And the next one is the name. And the name I can use in the command here. In the incoming command, there is the counter ID. That's one option. But this is also available on the context. Is the entity ID. I will use the entity ID, is the identifier of this entity, to fill in the name that I added here. This one. And the context is always available to your entity. And the entity ID will be whatever we use to call this counter. And a view. I will create a new package here in the protobuf folder. Call it views. And counter view photo. And I will copy here some code that I already prepared. And first, some basic protobuf configuration imports, I would say. Then I want to import the types that I have already defined here in my Kalix demo project, and I will define a service. And if you remember the previous one here, it was saying that we said to the code gen, that's a value entity. In this one, we're going to say to the code gen, that's a view. So first I will start with this message here, and then the updated methods, the query methods. Let me start with the updated method, and I explain what it is. So the updated method is saying there is a method that will receive counter state, that is the state of my entity, and will return current counter, which is that representation that I have that I want to expose to the external world. Then inside it, I have Kalix annotation saying, well, I want to subscribe to any change that happened on entities identified by this entity type, call it counter. And then I want those updates to go to the counters table. And now I'm going to define the counters index or table, which I do by create another method that receives a request and return a stream of current counters. And it will say, give me everything in the counters index, in the counters table, whose value is greater or equal the value that I get from my request. And you see here value, it's repeated here. So this field here will need to match this one, and that's what we get from the outside, and is used to execute the query. When we generate our code, we generate this main function, and we have one counter here, but now one component. But now we have two components. We have the counter and we have the view. So what I will do, I will delete this one, and I will let Kalix generate it again. I compile, and now let me close this one as well. And now I have the view, and the view receives counter state and return current counter. For the empty state in this view, we are fine to just say null, and for the update, we will just, for every time that we get an update, I will just return a new counter, current counter. Effect update state, and the first thing is the counter state is the value. The second thing is the name. But where I get the name here? Well, the name I will get from the update context. And the event subject here is the entity ID for the state that is being passed here inside. And that's my view. We have our view, and now I want to deploy it in production. So I will start SBT again, but then now passing my Docker Hub username to it, because I want to publish that image, that project on my Docker Hub account. To publish that Docker image into Kalix, normally you have to install the Kalix client. I have already done it, but for Mac you have a brew install. For Linux and Windows there are other tooling. You can have a look at all our documentation, but let's say I have it already installed. So the first thing that I will do, and I want to show you, of course I already signed up, but I want to show you that you can sign up from the command line. And you get this page where you can fill in, or you can connect with Google. I'm using here my Google account, my private one. I just continue, and I don't have any project yet. Okay, I sign up. I think I still need to authenticate. Let's see. Yeah, I want to continue. It will ask me to give authorization to the command line to have access to my Kalix project. Great. Now I will create a Kalix project. This one. I will create a new Kalix project, Kalix demo, Reactive Submit. And on this region, you can choose the region. I'm on Google Cloud, and so far so good. And let's see, the image got published. It's Octonato Kalix demo Reactive Submits, and then I can call this command in Kalix, which will create a new service, deploy something with this name, Kalix demo Reactive Submit, and that's the image that we are looking for, that it should look for to deploy. Okay, Kalix service list, yeah, unavailable, and now my service is ready. The next thing, so I want to be able to call it from outside. So I will ask Kalix to expose this service, and it will generate a URI for me, just one. And I will go back to my gRPC, and the port is 443. Okay. And everything that is greater than 10 there is nothing there. So that's it. So what we saw here is we can develop an application with very minimal code, just the basic, just explaining to Kalix what it wants for the views, explaining to Kalix what is the business logic, and all the rest is being taken care by Kalix. That's basically the magic sauce of Kalix, is giving to you an Akka cluster without asking you to manage an Akka cluster. You just write your business logic. How we can build a Kalix application, I want to go back to this slide here. And what we saw, it's a very simple application, of course. For demo, we should keep it simple and small. But imagine that you have a very big system, lots of counters, and at some point you need to scale out. You bring your code. Your code is just the counter and the view, and they are deployed there. But the state is managed by Kalix. And as I was saying, we do that by using the Akka cluster. So now your application is a clustered application and stateful, because the Akka cluster takes care of the state. At any single time, even if you have 20 nodes deployed, there is only one instance of each single counter in memory. Doesn't matter where, they will one instance over across the whole cluster, so that we manage the state for you. We managed a stateful Akka cluster application for you. You only bring your code, and that's the magic sauce of Kalix, is that it's allowing now everybody to build an application on top of Akka cluster without even dealing with clustering, database, Kubernetes and everything. You just bring in your code. We do the rest. Okay, before I wrap up, a small announcement or teaser for near future. We are working on the Spring SDK, which is based on Spring Boot, no protobuf encoding, just Java. You come, you write your code in Java, you use Jackson serialization, and you can use REST endpoints, define REST endpoints using Spring annotations. Thank you very much. I'd love you to try out Kalix. The demo code is on my GitHub account at github.com octonato/Kalix demo reactive submit. Stay tuned for the upcoming Spring SDK. That will be it's really shaping very well. I'm very happy with what we are doing there. And if you have questions, I think we still have some time for questions. I will be around. Otherwise, you can contact me at renato@lightbend.com, and my Twitter account is just octonato, like my GitHub one. Thank you very much.